Okay, let's continue the discussion about section 3.3. The next topic, what is this topic? 4, 5. Average rate of change. Of a function. Average rate of change of a function. Change means use a new value minus original value to subtract the original value. That's a change, right? So when you have a interval AB, if it's about x, what is the change from over the interval? So that's b minus a. That's from the initial value to the terminal value, okay? And the corresponding y value will be fb and fa. What is the change about y value? We do the difference. Is the change of y over ab. Well, rate of the change. When you see the rate, you have the quotient, okay? So definition, if a and b, here a, b are different, are distinct, are both in the domain, of a function y equal to fx, the average rate of change, average rate of change of f from a to b is defined as average rate of change. Well, let's not use this. That's a different one. Average rate of change is equal to fb minus fa. This is change of y over b minus a. This is change of x. In the short symbol, we can use the delta y over delta x, the difference of y value over the difference of the x value. Here we emphasize a is not equal to b. Denominator is not 0. Okay, so this is our average rate of the change. And this delta y is the change in y, okay? D. Well, that's a definition. Let's see how do we do a computation based on the definition. Find the average rate of change. The average rate of change here. Fx is 3x squared. It depends on the domain, interval. You have a b, okay? So let's say from 1 to 5. If it's from 1 to 5, a is a 1, b is a 5. So a is a 1, b is a 5. The average rate of change is f5 minus f1 over 5 minus 1. f5 is 3 times 5 squared is 25. f1 is 3 times 1. 5 minus 1 is 4. 3 times 25 is 75. 3 times 1 is 3. So it's a 72 over 4. What's this? It's 18. So the rate of the change is 18. From 1 to 3, let's check. From 1 to 3. If it's from 1 to 3, A is a 1, B is a 3. So it's f of 3 minus f of 1 over 3 minus 1. F of 3, the 3 times 3 squared. F of 1 is 3 times 1 squared over 2. 3 times 9, 3 times 9, 27. 3 times 1 is 3. It's 24 over 2. It's 12. Okay, so that's the average rate of the change. Let's see. Another B. So far, if we really want to figure out the value, possibly I cannot put some difficult functions. I can only give you the polynomials because it's easy to evaluate. So for example, if we put g of x equal to negative x cubed plus 1, then I say for the required AB from 0 to 2. So A is 0, B is 2. So it's g of 2 minus g of 0, 2 minus 0. FB minus FA, B minus A. Always is FB minus FA, B minus A. So g of 2 is a negative. 2 cubed is 8 plus 1. This is GB minus GA. It's 1. Right? 1A is 0. G of 0 is 0 cubed plus 1. Okay, this is a negative 8 over 2 is negative 4. And if we get from negative 1 to positive 1, let's see. So A is a negative 1, B is a positive 1. So this is a G1 minus G negative 1 over 1 minus negative 1. G1 negative 1 plus 1 minus G negative 1. Negative 1 cubed is negative 1. Negative of negative 1 is positive. Negative 1 plus 1 is 0. So it's minus 2 over 2 is negative 1. Okay, so that's our average rate of the change. Just follow the definition, okay? You don't have any difficulty to do the evaluation. You do the evaluation and do the quotient. There's one concept, geometric concept, related to this average rate of the change. It's called the second law. What is the second law? So for example, you have a graph of a function like this, and the second line means that the line contains 2 points from the graph, like this. So let's first give the definition. What is the second line? The line containing 2 points from the graph is called a second line, or the second line. Okay, 2 points. So you have it. You have this point A, FA, this point b fb, and function is y equal to fx. AFA BFB. Okay, you have a line. Whenever you have a line in geometry, one of the important quantity is the slope. With 2 points, how do we compute the slope? The slope read it. Yes. The slope of the second line is, what is the slope? Slope is rise over run, right? So let's check. Rise FB minus FA. Run B minus A. So the slope is rise over run is FB minus FA over B minus A. So that's a geometric concept. Check this. This is exactly the average rate of the change. So theorem, slope of the second line the average rate of change of a function from A to B equals the slope of the second line containing the 2 points AFA and BFB. Okay, so that's the theorem. The slope of the second line is equal to the average rate of the change. So in the examples, you can say, let's try to find the average rate of the change from one point to another point. Or you can also say, let's try to find the slope of the second line from that point, the same pairs of point. It's just the same quantity but with 2 explanations. Okay, so let's check. Suppose g of x is equal to 3x squared minus 2x and plus 3. And first, find the average rate of change of g from -2 to 1. So -2 to 1. And second, find an equation of the second line. Find the equation of the second line containing negative 2, g of negative 2, and 1 g of 1. Okay, well, the rate of the change, average rate of the change. G1 minus G negative 1, 1 minus negative 1. And G1, 3 minus 2 plus 3. G negative 2, 3 times 4 minus 2 times negative 2 and plus 3. 1 minus negative 2, right? And you simplify it, you will get, so 3 minus 2 is a 4, 1 plus a 3 is 4, 4. And you compute this, you will get 19. It's 12, 12 plus 4 is a 16, plus 3 is 19. So this is a negative 15 over 3 is negative 5. So that's our average rate of the change. That's the slope of the second line. So the slope of the corresponding second line is negative 5. The slope, we only talk about slope. And you have a slope, you have 2 points, so you're going to pick up 1 point. So choose, I'm going to choose this 1g of 1 because this value is easier. So 1g of 1, which is 1, 4. Then we have a point slope, y minus 4 is equal to negative 5 x minus 1. Y minus 4, negative 5 x minus 1. So y minus 4 is equal to negative 5x and plus 5. You move 4 to the right side, it's negative 5x and plus 9. That's it. That's the equation of the second line containing the point negative 2, g of negative 2, and 1, g of 1. Right? So in this part, in this short video, we only discuss technically one computation, average rate of the change. That's one computation. But this computation can be considered as a computation of a slope of the second line through to given point. And when you have the slope, you use point slope form to write down the equation of the second line. That's important. You should be able to write down the equation of the second line based on the average rate of the change plus additional point. Anyone. You can choose this 1, 4. You can also choose a point negative 2 g of negative 2. The textbook choose a negative 2 g of negative 2. It's the same. After simplification, you get the same value. But at the point slope form, of course, they are different. Point slope form is different from here, but the final one is the same. Okay, so we finish this short section. We will continue another section in a different video. Okay, thank you.